Hey everybody, this is Larry. This is day 10 of the October Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. 10 days in a row, or 9 days in a row, I guess, so far. Good for you. Come and hang out and we'll, chat on Discord. The new timing is a little bit, maybe, I wouldn't say awkward, but maybe it's a little awkward. Because in about an hour and a half, or maybe a little bit longer, it's going to be the weekly contest. So hopefully we'll see how that goes. But also maybe it just sets a good practice for me to before that contest. So we'll see. Anyway, today's problem is bitwise n of numbers range. So okay, given two numbers return a bitwise n of all numbers in this range inclusive. Okay. I think this feels like okay. It's not that bad. I don't think it should be, but it is like almost a brain teaser-y thing of just following through your logic, right? So the naive thing that I might have first thought of is, okay, oh yeah, just do a for loop. But then the second one is, okay, well, what are the constraints? Well, the constraints are here. And now we know that we probably should do a little deeper, and they're not, at least for this particular one, they're not trying to fool you or anything. It's in the example, though sometimes even if it's an example, it fools me because I'm easy to fool, it seems like. But in either case, yeah, but then the thing that about bitwise operation is that let's see, what was it say? Every bit is independent, right? So then now we think about every bit by itself, and I think along those lines, for example. You can think about this odd and even, right? Like for example, if a range contains odd and even numbers, then the last bit is going to be, the n is going to be 0, right? So then the question is, can we recursively think about it that way one bit at a time? And yeah, I think that's maybe the way that I would think about it. It doesn't have to be recursive in implementation, but it's about like, okay, what is this equivalent of, right? So okay, so let's just say 5 and 7. And there may be a little bit of 5, 2, 7, but that's confusing. But yeah, but there may be some off by 1, but we're just playing around with thinking through this logic and stuff like that. And as we said, okay, are there both even and odds in this range? If so, then obviously this is going to be 0 because 0 and 1 is going to be 0. Or actually, I guess maybe a better question. Maybe I phrased this incorrectly, actually, because it could have 0 and 0 and it's still 0, right? So actually maybe the better, more precise question now that I think about it, and I am solving these live, so yeah. So the question is, are there only ones, or are there only odds in this range, right? And yes means it is a 1, no means 0. And I think that's basically it. And then the recursive question is, okay, now we want to look at the second to the last digit, right? What does that mean? That means that as I said, maybe there's an off by 1 in how we do it, because maybe round up, round down, I have to think about it a little bit. But then now you look at every range, and actually maybe there's no worry about off by 1. Let's rewrite this as a binary number, right? So a binary number, 5 is 101, 7 is 111. So this, right? Yeah. In this case, obviously, are there only odd numbers in this range? The answer is no. So the answer is 0. And then now we look at one digit to the left, and we go 0 and 1, right? And then the question is, are there only one? Are there only ones in this range? And the answer is no. So it's not a 0. And then now we go to the last digit, and it's 1. And then the answer is yes. So it's 1. I think that's maybe good enough for us to kind of get started. I mean, I think this matches kind of the answer here. I think the thing that you might wonder is about explanation, because it's not just about taking the last two numbers. It's just about all the numbers here, whether they're the same, right? So the only way that there are only ones inside a given range, of course, is if they are the same number to the left of it, right? Like if the number is 1 and all the prefix is the same, then there's 1, because anytime you have more than one number in a range, in a consecutive range, that's going to be 0. So okay, so I think that's basically how we're going to implement it, and that's how I'm going to think about it. right? So let's go. Let's see. Let's just say answer is equal to 0. We return answer at the end. And then we do it one by one. So while left is greater than 0 and right is greater than 0, because anytime that's no longer true, then it's just gonna be 0 anyway, right? Because, you know, for example, I guess we've only been doing numbers that are in the same digit, but for example, if you have something like this, you know, well, we know that this prefix are going to be 0, so it doesn't even matter at that point. But yeah, so okay, so then now we do how do I want to phrase this? But yeah, let's just do the bit. So the bit is equal to left mod 2 and how do I want to phrase it? This and, I mean, I know that you can use Boolean to int type logic here, or int to Boolean logic, but I want it to be more precise, and that's why I wrote this. Yeah, maybe, I don't know, because this is still a Boolean, right? So yeah, so this is the bit. So initially it has to at least be true that the last digit has to be 1, because if it's 0, then it already is a 0. And then is this and left divided by 2 is equal to right divided by 2. As we said, the prefix has to be true, and even though you just be careful that you cannot multiply by 2 on both sides, because these are integer divisions, right? So it's not closed. Okay, so if bit, then answer we at 1, I guess, and then maybe we just do an offset. Okay, right. Yeah, and then of course we shift, so we divide by 2 on both sides. And I think this is maybe good enough. It represents a lot of the ideas that we had, but okay, maybe not. Whoops. I just wanted. It's so hard to click on this and not click on the, like, this is such a weird target area, right? Okay, I mean, I know that I saw the wrong answer, but I was just playing around with it. Okay, so I mean, I think our logic is right. But clearly the answer is not. So yeah. Oh, I'm being dumb. We only okay. I think this should be good. I think I was only shifting offset when we add, which is clearly not true, because we care with digit by digit. Okay, and then let's play around with some extra cases. Let's see what I think actually the cases they have here are actually mostly reasonable. I don't know, 5 5 6 6 7 9 maybe, I don't know, but I feel like we're mostly done. Maybe just, and I imagine now, I was gonna say maybe there's an edge case on 0, but on our implementation this wouldn't even run, so it just returns 0 by default. Okay, so let's give it a submit. I did it a year and a half ago. 558, nice. Cool. Yeah. What is there to say? So what is the running time of this? This is going to be linear. Linear, of course, it is linear in the size of the input, and the size of the input are 2 ints, which means that for a number left is equal to m, say, then the size of the input is going to be O of log m, because that's the number representing the bit, and of course this we divide it by 2 every time, so this is going to be O of log m, right? And let's say maybe left, whatever, something like this. Doesn't really matter. I mean, I know that right is actually bigger than left, but I'm just being a little bit lazy here. But yeah, and this is linear time because log m is the size of the input, and this takes log m time. In terms of space, these things are always a little bit tricky because it's also log m, right? Oh, yeah, it's also log m space, because in the worst case it'll take exactly the input, so this is also going to be linear space. So linear time, linear space. These things are always tricky because when people say linear, I think a lot of people are conditioned to think that this is O of n, but of course, it is only O of n if n is the size of the input. But or at least linear is O of n if n is the size of the input, but sometimes n is not the size of the input, right? N can, or in this case, I use m to be a little bit less confusing, but because the size of the input is log m. So yeah, so this is linear time, linear space. That's pretty much all I have for this one. Let me know what you think. Yeah, okay. Good luck on the contest in an hour and a half or whenever it is, if you're doing it. If not, come hang out afterwards or whatever. That's right. Stay good, stay healthy, to good mental health. I'll see you later. Bye bye.